Venn diagram. So this Venn diagram is the most commonly used for pictorial representation of the sets. To use with diagram wise, to represent the sets with diagram based. So we can use this Venn diagram. So the idea was given by the first developed by John Venn. So on his name we can use this Venn diagram, right? So when you come to this pictorial representation of these sets, one by one, let me show you. If you take one rectangular shape, in case this is the rectangular, it's a rectangle, take it as a U. So think it's a universal set. Inside set A and set B, having two sets. Let's take this is A and B. So A having only 1, 2, 3, set B is having 5, 7, and somewhere is 8 is outside. This is from universal set. 1, 2, 3, 5, 7, 8 are the elements from universal set. 1, 2, 3 from set A and 5, 7 from set B. That means A and B are the disjoint sets because there is no any common. So disjoint sets it is. To represent the disjoint set, we can use in this way. And instead of that, if you want to join sets, two sets are joined. That means there should be some common elements. If any element is common, we can join the sets in this type. Okay, which is the common? No, in this common place. Like 1, 2, 3, 5, 7, like A and B. Universal set is this. That means set A is having 1, 2, 3. Set B is 3, 5, 7. And 3 is the common. So common element should be in this. This for the joint or disjoint sets we can represent. And subsets. So set A is this. And inside there's one more set B. Every element in set B is belongs to set A. So we can take it as B is subset of A. And in set B, if you take the set A, then that is A is the subset of B. And let us see the shaded like union intersection also in this Venn diagram. So this is the rectangle. For universal set we can represent this type. And union, intersection and difference. 3 I'll show, 4 I'll show here. Difference also 2 cases. Let me take the 4 rectangles. Union, intersection, difference, right? Previous we discussed the in problems. Now here is set A and it is set B. Set A, set B, set A and set B. Venn diagram to represent. Let us take this the A, B, same. A, B and A, B, A, B. First one, A union B. So A and B, all the elements. So we should shade everything. So this representation is A union B. A and B, all the elements together. And A intersection B, only common. So this is only the common element. So this is the shade here. So this is the shaded part now. We can take this. So represent this shaded part is A union B. This is A intersection B. Next, A minus B. So A minus B is from A. B should be removed. That means only this remaining. Okay, this shaded part is A minus B. Same way here is B minus A. From the set B, if you remove this A, only this. Not even common. Okay, this is the shaded region is B minus A. In this diagram, shaded region is A minus B. In this way, you can represent the Venn diagram based on the shaded union, intersection, those and all. And only the common is here. Let me take one question. How the questions will come based on this Venn diagram and problem. Let us discuss. Okay, so given universal set is given X such that X belongs to natural number 12 less than or equal to X less than 20, and set A is X such that X is divisible by 3 x is divisible by 3 and set B is equals to 12, 14, 15 and 16. Now draw the Venn diagram to show the relation between the given two sets. Between A and B, what is the relation you have to show using this Venn diagram? Now when you come to this solution, here is a set A. X is divisible by 3. But A and B should take only from universal set. So universal set is from 12 to 20. Not even 20, 19. 12 to 19. So between 12 to 19, divisible by 3 is 12. Again 15, 18. That's all. This is only from set A. B is given already 12, 14, 15 and 16. Now this data to represent on the using this Venn diagram. Take this rectangle. This is universal set, right? All the elements. So inside we have set A and set B is a common. Let us take this A and B. First 12, 15, 18, 12, 14, 15, 16. So 12 and 15 are the common. You should write 12, 15 is here. 12, 15, no, remaining is 18. In set B, 12, 15, next to 14 and 16. 14 and 16 are here. This is how A and B are fixed. But when you come to universal set, 12 to till 19. So 12 is there. And there's no 13. So in the universal set is full box. And 13, 17 is missed and 19 is missed. Those you can represent in the remaining place. Don't write within the A and B. So based on this, A intersection B is 12, 15. A union B is 12, 14, 15, 16, 18. So based on this, you can write A minus B, A union B, A intersection B, all the points in case they asked in the question. So A minus B if they asked. From A, if you remove this B, only 18. And B minus A is 14 and 16. 14, 16. And A union B is altogether in the A and B. That is 12, 15, 14, 16, 18. And A intersection B is only 12 and 15. So any question is given, using this Venn diagram, easily we can represent, right? So these are the main concepts based on the Venn diagram. Mostly you can see in your syllabus, like union, intersection and differences. Those you can expect some questions. And based on that, you can ask the word problems, even this numerical sums, right? So those are watching the first time our channel, you can subscribe to it, and to understand the concepts clearly, just follow in order one by one.